Hello friends, let us today study a very important process which takes place in fats and oils or the products containing fats and oil, and this is known as rancidity. Rancidity is the natural process of decomposition of fats or oils leading to the development of undesirable flavor and odor, and this process, that is the development of undesirable flavor and odor, is either by hydrolysis or by oxidation. So, because of this rancidity or hydrolysis or oxidation, the lipids or fats, oils degrade to the point of becoming either unpalatable or unhealthy to ingest. Different causative agents or causative factors for the rancidity include heat, light, radiation, water, enzymes, even catalysts like metal ions etc., acids, alkali and salt. And these are the conditions or agents to which the foods containing fats and oils or even the individual fats and oil, they come in their contact during various operations, like they come in contact with the heat when the oils or fats are cooked during frying operation etc. During storage they may come in contact with the light. So, all these factors cause changes into their odor and flavor and big about certain changes in the nature of the material, characteristics of the material. So, as I told you that the rancidity, this may be broadly categorized into three groups, that is the hydrolytic rancidity, oxidative rancidity and ketonic rancidity. The hydrolytic rancidity, which is also commonly known as lipolytic rancidity, and here as the name itself indicates, hydrolysis of the ester linkage of the triglyceride is primary event. Means that is the hydrolysis means, you can see here in this figure, that is a triglyceride contains, that is the 3 fatty acids attached with the glycerol molecule. So, when this ester linkage is hydrolyzed, depending upon the extent of hydrolysis in the system, you will get more free fatty acids, plus there may be some monoglyceride, there may be some triglyceride and triglyceride. So, in fact, oil generally are fat which was earlier a triglyceride, because of this hydrolysis it becomes a mixture of rather triglyceride, diglyceride, monoglyceride and free fatty acids. And this hydrolysis may be caused by the different agents like moisture, heat, light, alkali, acid, enzyme like lipase etc. And this, when alkali is the hydrolyzing agent, then this like sodium hydroxide or potassium hydroxide etc. So, this alkali reacts with the released free fatty acids and sodium or potassium salt of the respective fatty acids are formed, and the resultant product is called soap, and actually that is the principle of the soap formation in the industry etc. There is the free fatty acids or fatty acids are allowed to react with suitable alkali. So, this process is called saponification. Otherwise, when other causative agents bring about hydrolysis, the process is called that is lipolysis or hydrolytic rancidity or lipolytic rancidity. So, mind it, here the change is in flavor is mainly because of the flavor of the fatty acids, free fatty acids content in the oil increases. So, most the free fatty acid they might have their characteristic flavor. So, change in the flavor is because of the free fatty acids. Okay. And but one important thing is that the developed free fatty acid, it depresses, rather seriously depresses the smoke point of the oil, and this affects the cooking or frying qualities of oils and fat. For example, cottonseed oil which has a smoke point of about 232 degree Celsius, even 1% development of free fatty acid in the aisle, cottonseed aisle, reduces its smoke point to 160 degree Celsius. Means there is the cottonseed oil which was earlier able to be heated up to 232 degree Celsius. If it has 1% developed free fatty acids, it cannot be heated more than 130 degree Celsius. So, the its frying qualities, and moreover that is the products when they are fried in a oil which has more free fatty acids, there is more absorption of oil or fat by the products, and also the products they tend to develop more browning and they give the cracked surfaces, that is the smoothness on the surface may be not there. So, these are the some of the problems. So, that for that reason this rancidity or hydrolytic rancidity should be avoided. Other is the oxidative rancidity. You know that oxidation is the process, okay, which where this addition of oxygen takes place in the molecule. Okay. It may be a photooxidation, it may be autooxidation or enzymatic oxidation. So, this oxidative rancidity basically is caused by oxidation of the unsaturated fatty acid, okay, in the chain, and because of the spontaneous nature of the reaction, the process is frequently referred to as autooxidation, and the oxidation of unsaturated fat in food is generally mediated by free radical which are formed through a complex series of reactions. So, I told you, see here is the oxidation, the process of addition of oxygen or removal of hydrogen or electrons, and the oxidant or oxidizing agent is an element which causes, there is a element or compound that gain electron or get reduced. In the food system generally oxygen is the most common oxidant, and the factors influencing the oxidation process are heat, light, ionization reactions, and trace metals like copper and iron ions, even enzyme lipoxygenase, there is lipoxygenase which add oxygen to the lipid, and metalloproteins such as heme, etc. So, the lipid oxidation may be of two types. You can see here in this picture, actually it is the oxidation, that is the more degree of higher the degree of unsaturation, the higher is the instability or the more prone the oil will be to the oxidative process changes or oxidation reaction. So, oxidation of highly unsaturated fats, they may result to the polymeric end product formation, whereas oxidation of moderately unsaturated fats results into the development of rancidity, reversion, off flavor, odors, etc. So, the depending upon the stages of the oxidation, extent of oxidation, different products are formed, and accordingly they are the primary oxidation products. The primary oxidation product decompose into secondary oxidation product, and which may further may be oxidized into tertiary oxidation product. The primary oxidation products in the fats and oils include hydroperoxide. Secondary oxidation products may be aldehydes, ketones, dienes, trienes, etc. And the tertiary oxidation products are acids, epoxide, dimers, and oxygen rings, and so on. These lipid oxidation has several influences on the quality of the products or lipid or fats and oils. There may be flavor loss like rancid flavor or change in the color and texture of the food, nutritional quality loss, particularly the essential fatty acids if involved or vitamins, etc. Their quality is even this may be lipid oxidation end products, may be sometime health risk also. There may be growth retardation, heart diseases, etc. are sometime reported due to the oxidation products, or ultimately the consumer acceptance of the product is adversely affected. So, there is economic loss. As far as the nutritional significance of the lipid oxidation is concerned, there are certain products which are formed, which might be formed as a result of oxidation of lipids or fats, which have important influence on the health. Like for example, peroxidized fatty acids, they destroy both vitamin A and vitamin E in foods. Similarly, polymeric materials may be formed which may have different effects. Oxidized sterols, they are thought to be involved in the causation of atherosclerotic disease and so on. There are several examples. So, the lipid peroxidation or auto oxidation of lipid, okay, or oxidative rancidity is take place through, as I told you, chain reaction, that is the free radical chain reaction, and it takes place in 3 stages: initiation, propagation and termination. In the initiation stage, that is an alkyl radical is formed either by abstraction of hydrogen radical, okay, or by addition of oxygen molecule. In the propagation, these alkyl radical react with oxygen at a rate controlled by diffusion to form peroxy radicals, which in turn react with new lipid molecule, giving rise to hydroperoxide as primary oxidation products, and new alkyl radicals that propagate the reaction chain. In the termination, in fact, 2 radical interact and react to form a non-radical compound. This is generally the end of the, but this is a continuous process. Once that free radical chain has started, the mechanism has started, if not taken care of, this may take place simultaneously. So, you can see here in this just we have tried to show you that this RH, if you take a lipid molecule or fatty acids, then it gets either hydrogen atom or the alpha methylene group of the double bond is removed to form an alkyl radical and a hydrogen free radical. Okay. That is the initiation. So, once these reactions are initiated, then the propagation is when these unstable free radicals, they are which are formed, they may interact with themselves or they may interact with other molecules, fatty molecules, like here you see R plus O2, it forms ROO. RO free radicals, it reacts with another lipid molecule here and gives you ROH plus another alkyl free radical, alkoxy free radical is formed. So, in the process, that is the reaction continued propagates, ROH is converted into RO plus OH free radical. Then this RO free radical which is formed here, it reacts with or interacts with another new RH molecule, it gives ROH plus R free radical. So, in this process, the reaction proceeds with the times and even the reaction rate etc. increases with the progress of time, if not checked or if not controlled. In the termination, it is, I told you, it is marked by slowing or stoppage of the reaction, where there is 2 radicals combine with each other to form non-radical products, like R plus R gives RR, 2 RO it gives ROOR, RO plus R it gives ROOR. So, different non-radical compounds which are hydroperoxide, other compounds are formed here in the termination process, and these different new organelle or hydroperoxides thus formed, they may, depending upon the conditions prevailing in the system, temperature, pressure, other environmental factor, water activity and all those things, they may get decomposed, that is they are rather readily decomposed by heat, metal catalyst, enzyme activity etc. Okay. That is ROH, RO free radical again OH, or this ROH, RO plus ROH and plus H2O, and this process continues. In fact, the radical formed from the hydroperoxide undergo a series of reactions leading to several products such as hydroxy acid, keto acids, aldehydes and so on. The short chains acid derived by their oxidation are largely responsible for the undesirable flavor and other characteristics of the rancid food. So, you can see here in the different, that is the whether it is hydrolytic rancidity or oxidative rancidity. In the hydrolytic rancidity, the changed flavor is mainly because of the development of free fatty acid. So, it is the free fatty acid flavor, but here in the case of oxidative rancidity, in fact, many new compound like hydroxy acid, keto acids, aldehydes etc. are formed, and the flavor is because of these new compounds, and at times maybe that these new compounds which are formed, they may be even carcinogenic or toxic also. So, in fact, I told you there are certain agents which are pro-oxidant or which accelerate the rate of oxidation reactions, and metal is one that is the. So, hydroperoxides and the trace heavy metals, they are present in the lipid. So, this metal act as a initiator or it initiate the generation of free radicals. So, transition metals, metal ions are good promoter of free radical reactions. They decompose the hydroperoxide from peroxy and alkoxy radical, as you can see here, ROAH plus metal ion, RO plus HO plus Mn plus 1, RO M plus 1 gives RO plus H ion and Mn. So, this metal ion, it again comes back to the its earlier form in which, but it has done its job, it has done the initiation reactions are helped in the free radical chain reactions. Then enzyme oxidation, that is the oxidation catalyzed by enzymes in unprocessed foods or in the fats and oils, and it is the enzyme basically lipoxygenase. In the lipolytic rancidity, it is the lipase enzyme the one which breaks the ester linkage, but lipoxygenase enzyme, it adds oxygen to the lipid molecule. You can see in this reaction picture, that is the unsaturated fatty acids at the point of unsaturation, this lipoxygenase enzyme, it adds oxygen here. Okay, that is. So, it add, that is the oxygen or catalyze the oxidation of free PUFA, which is released from glycerides by the action of lipolytic enzymes. Okay. So, the first step of the enzymatic oxidation is lipolytic degradation of the triglyceride, maybe lipase enzyme or other factors, they may release the free fatty acids. So, this unsaturated free fats, they are more prone to the enzymatic oxidation. So, oxidation products, and otherwise once they are oxygen get, then the free radicals are formed, and then the free radical, that is the propagation, termination and other things, it takes place in the usual manner as we have seen in the earlier case. Similarly, the photooxidation, that is the hydroperoxides formed in presence of light and photosynthesizers. Okay. There are various pigments present in food like chlorophyll, homoproteins, riboflavins etc., chlorophyll, hemoprotein and riboflavin etc., and these photosynthesizers are activated by absorption of light and the excited species. The activated species act as a single free radical initiator by transforming electrons to lipid to form radicals that react with the oxygen in the same way as we have discussed in the earlier auto oxidation process. So, you can see that the sunlight etc., it passes, that is when it falls on the food, that is the food contain that is a maybe natural pigment like chlorophyll, pheophytin, etc., at high step, erythrocin, methylene blue and all those things. So, these are considered to be photosynthesizer. So, they convert that is the triplet oxygen into singlet oxygen, and this singlet oxygen then it provides oxygen and causes the oxidation of the unsaturated fatty acids. So, in this way, that is why one reason, that is the oils, particularly polyunsaturated oils, etc., they should be stored in a dark place. Their exposure to direct sunlight, etc., should be avoided, otherwise it will catalyze their oxidation and the oil will become rancid. Ketonic rancidity is another type of rancidity. It is the most frequently encountered as a result of action of fungi such as Aspergillus niger and blue green mold like Penicillium glaucum on coconut oil or such other seed oil, and they develop some sort of peculiar flavor or odor like tallowy odor, say, and this tallowy odor in fact the developed is mainly due to the formation of aldehydes or ketones, and these aldehydes or ketones are formed by the action of enzymes present in the fungi. So, the fungal enzymes, they act on the oil or fats, particularly the oils and fat which has short chain comparatively more saturated fats with short chain fatty acids, they are more prone to oxidative rancidity, to this ketonic rancidity. So, as I told you, it is due to the conversion of short chain fatty acids by some moles to a homologous series of aliphatic methyl ketones, pentane 2-one, heptane 2-one, nonanone 2-one and so on. So, the essential prerequisites for the formation of ketonic rancidity appear to be the presence of moles, a low water activity in the system, a low partial pressure of oxygen and the presence of short chain fatty acid in the medium. Yes. Okay. So, now another important aspect is how to measure rancidity in food material. There are different, because there should be methodology, one should be able to know that is the developed rancidity, right. One important method is that is just by visual observation or just by sensory, by smell, by seeing the smell we can say that yes, one can say that is whether this oil is rancid or not. Okay. But there are certain methods like there are two ways the methods available, they can be two types like direct measurement of the free radicals like electron spin resonance method or spin trapping methods, or indirect approaches can be used to measure like thiobarbituric acid, reacting substances, because, or gas chromatography can be used, because during this rancidity either in the oxidative rancidity or hydrolytic rancidity there is the different aldehydes and other compounds are formed, free fatty acids are formed. So, these carbonyl compounds they can be spectrophotometrically they can be measured, even free fatty acids can be measured, or the peroxides can be measured using peroxide value, etc. The conjugated diene, anisidine value or lipid chromatography, fluorometric compounds, etc. So, there are different methods, both indirect method as well as direct approach for measuring free radicals can be used to measure the rancidity, both oxidative, hydrolytic or ketonic. Okay. I told you that is most commonly it is detected by odor or smell. Okay. And regarding the peroxide value or the measurement of the primary oxidation product, the peroxide value is generally measure of the peroxides contained in the oil. The peroxides present are determined by titration against thiosulfate in the presence of potassium iodide. Starch is used as an indicator. Anicidine value is measured for the determination of secondary oxidation products. It accesses the secondary oxidation product of oil or fat, which is mainly imputable to aldehydes and ketones, and is therefore able to tell the oxidation history of an oil or a fat. Furthermore, anicidine value of an oil is an indicator of excessive oil deterioration in deep fat frying. So, anicidine value, peroxide value or such other measurements, thiobarbitoric acid test number etc., they can be used. Even oxidation products of unsaturated system produce a color reaction with the thiobarbitoric acid, and the color here mainly is the manolaldehyde or such other aldehydes present in the system. So, many alkanols and alkenols produce yellow color compound, dienols produce red color pigment at 530 nanometer range of the spectrophotometer etc. So, these various approaches. Apart from this, even the Rancimet system, where oxidation stability or induction period of a oil or fat can be measured, and which gives the suitable idea of the how prone the oil is to oxidation or how much stable it will be. So, depending upon induction time etc., can be calculated. So, there are different methods in the available which can be. So, you have seen now that this rancidity is a problem, particularly phenomena of the rancidity, like in the case of polysaccharide or sugar containing or carbohydrate containing foods, browning is the major process. In the protein or protein related food, denaturation and other processes. Similarly, here in the lipid and oil or the food containing higher lipid and oil, lipid peroxidation or lipid oxidation or lipid hydrolysis becomes major problem, which result to the change in their flavor, in their odor etc. So, obviously, the appropriate methods, appropriate means should be followed to prevent them, and accordingly the methods to prevent them are derived from those factors which accelerate them. Okay. So, like the oxidation. So, oxidation, there are pro-oxidant, there are antioxidants. So, using appropriate antioxidants, this oxidation can be avoided. Similarly, elimination of oxygen from the, that is by keeping the oil or fats away from oxygen, either by nitrogen flushing or by vacuum packaging etc., or even avoiding their contact with photosensitizers, direct exposure to light etc., direct contact with light, or even by using appropriate mean to denature the causative enzymes like lipases, lipoxygenases etc., or even low temperature and dark room storage of the. So, these are the some of the ways by which one can minimize the rancidity of oils and fat. In fact, the oil, refined oil and such other oil which are available in the market for cooking and frying operations, they are extensively, that is to improve their stability, the industry uses antioxidants in them. So, they are all antioxidants are added into it. So, they become very valuable component in the oils and fats. So, we will take up this aspect separately maybe in the next class, that is what are antioxidants, both synthetic and natural antioxidants, what are the different types of antioxidants used in different oils and fats, and how they interact with autooxidation or free radical chain reaction mechanism, and how they give or stabilize oils and fats. All these details we will take up in the next class. So, with this I thank you all for your kind attention.